Now for this one, we need to find the derivative, and in general, when you look at the outside, it's kind of like a product rule, but within the product rule, we have this u to the v, and then this one is something like, let's say, a to the u. So it's something like that, and then after internalizing that kind of idea, so let's just proceed with differentiation. So we have y prime that is equal to, since it is product rule, let's try doing it. So we have x to the 2x. I'll just copy it because we're doing product rule. And then for this product rule, we have to differentiate 5 to the x. So we have to multiply this with the derivative. So we have 5 to the x, and then we have ln of 5, and then we take the derivative of x, which is actually 1. Okay, then we add 5 to the x, and then we differentiate this. So I'll just be using the direct method so that I won't be having to take the ln of both sides. So with this, we have 2x, and then times x raised to 2x minus 1, and then we differentiate x, so that's times 1, and then we add, just copy x to the 2x, and then we take the ln of the base, so that's x, and then you differentiate the exponent, so that's simply 2. Okay, so with this, I've minimized the steps. So with this, let me just simplify this. So what we have is, I think that's x to the 2x, and then times, let's just have x to the 2x, 5x, 5 to the x, and then ln of 5. Then we add. So with this, we have 5 to the x, and then times, I think we can actually add the exponents right from here. So we have something like 2 raised to x, I think, and then with this we have 2x plus x, plus 1, so we have raised to the 2x in this case. And then we add, so we add 2, and then x to the 2x, and then ln of x. Okay, so with this we can actually factor out the expression further, add. So 5 to the x, and then this can be added or factored out. In this case I'll be factoring out 2x to the 2x, and then we have 1 plus ln of x. And in this way, we can factor out 5 to the x from this expression, and of course x to the 2x. So we have 5 to the x, and then x to the 2x, and then we're left, in this case, ln of 5. And then for this one, we have plus, we factor out this one, so we'll just be left with 2. So we have 2 times 1 plus ln of x. Okay, so simplifying further, we have y prime is equal to 5 raised to x times x raised to 2x. And then in this case, if you want to try to add this, we have ln of 5 plus 2 plus ln of, 2 ln of x. So we could just write ln of 5 plus 2 plus 2 ln of x. Okay, so the answer here is given something like this. Okay, that's ln of 5 plus 2 plus 2 ln of x. So we actually got the correct, the exact answer. And we can also do something like this for the answer. This will do 5 to the x, and then x raised to 2x times, we can do something like ln of 5, and then plus 2 plus ln of x squared. Okay, and then by the property of ln, you can actually try to do something like ln of 5x squared, because remember, this is a property of ln wherein if you have addition of the natural logarithm of a certain number, you can actually do this. In this way, we can also rewrite this as 5 to the x, and then times x raised to 2x, and then we multiply this with 2 plus ln of 5x squared. Okay, now when you're having doubts with your answer, you can always check your answer by substituting any value of x. if your simplifying is the same. For example, if you have x, let's say you don't select something like 1, 2, or 0 because it's kind of critical for this kind of expression. So what I'm suggesting is you use something like rational numbers, for example 2.5 or 5.7, something like that, so that it's not a whole number. So if you try to substitute that at any value of x here, so you'll be able to get the value of y prime. It should be equal to the value that you'll be able to get here, because if that's the case, then your simplifying is correct. Now let's have another one, and I think this will be the last one. Okay, so for this example, we have the hyperbolic sine of ln of x plus cosine raised to sine x of x. So I think this will be kind of long, so I hope it fits on the space that we have. But anyway, so let's proceed. So as you can see here, this is a composition function. I'm internalizing right now. So this is a composition function with ln, of course. And then this one is something like u to the v. Okay, so that's for our solution. So we just have to take the derivatives for each of them, and then we're done. So f prime of x, we start with this, and then the derivative of the hyperbolic sine of ln of x is simply cosine hyperbolic, and then we have ln of x. And remember, you have to take the derivative of ln of x, so that's simply 1 over x. Okay, and then we proceed with this one. So we have plus the derivative of cosine raised to sine x times x. So I'll just be using the direct rule. So I will be getting, now what I want to tell you is that the direct differentiation rule for this is kind of easier to use, because instead of taking the ln of both sides here, you'll be something like transposing this first before you could take the ln of this expression. In that way, you'll be having something like an expression expressed in terms of f of x minus this expression. And then if you take the natural logarithm of that, then you'll be having something like a chain rule when you try to implicitly differentiate it. So of course you might want to try that, but I'll just proceed with the direct differentiation here. So we have sine x times cosine of x, and then this is raised to I'll just be using this sine x minus 1. That's not x minus 1, that's actually just minus 1 from the whole sine x. So I use this expression because it's kind of difficult to move this or write it here right above this cosine. So with this I need to take the derivative of cosine of x, so that is simply times negative sine of x. Okay, then we add, because that's under rule. So we copy this cosine raised to sine of x, and then we need to take the ln of, or the natural logarithm of the base. So that's simply ln of cosine of x. Okay, and then it's no longer, it cannot fit anymore in this case, so I'll just move it somewhere here. And then so we proceed. So you copy the expression, you multiply that with the ln of the base, and then you multiply it with the derivative of the exponent. So the derivative of the exponent is simply cosine of x. Okay, so we're done with the derivative. We just need to simplify this. So we have I think that's hyperbolic cosine of ln of x, and then we divide this by x, and then we can actually subtract this with sine squared x times cosine of x raised to sine of x. And now I'll be writing this at the denominator so that I don't know, it looks pleasant, because it's kind of crowding here at the top. So plus, we can have cosine raised to sine x plus 1 x, and then ln of cosine of x. Now if we try to give the expression for this one, we know very well that if we have a hyperbolic cosine of x, that's actually equal to e raised to x and then plus e raised to negative x all over 2. So if you try to do that here, e raised to ln of x plus e raised to negative ln of x and then divided by 2. But of course we have x here, so we just need to copy that, and then minus. So I just actually written cosine of x at the denominator. Now I'll be moving it at the same expression right here because I want to show you that I'll be doing something like 1 minus cosine squared x here just to give the equivalent of sine squared x, so that all the expressions are in terms of cosine. So that's actually sine of x minus 1. Okay, so this expression, this cosine of x, is raised to this expression. Then plus this one, I can't do anything about this, so I'll just copy this one ln of cosine of x. Then I guess I'll just write this the same way I did for this one. So that's actually sine of x plus 1. Okay, so I think that this looks better. So with this, that is equal to, we know very well that if it is e raised to ln of x, that becomes x. Then this one becomes x to the negative 1. Okay, so with this simplifies further in this expression. And then I think this one becomes minus cosine of, so this becomes cosine of x raised to sine of x minus 1. And then this is kind of subtracted with, I think that will be cosine of x, and then of course raised to sine of x, and then this minus 1, so this is actually squared, so that's plus 2, so that becomes positive 1. Okay, and then we add this whole expression right here, so that becomes ln of cosine of x, and then that's cosine of sine x plus 1 and then of x. Okay, so I can just write f prime of x. Now this can be simplified further into x plus 1 over x and then divided by 2x. So we also have something like minus cosine of x raised to sine of x minus 1, and then we have minus, so that becomes plus, so we have plus cosine raised to sine x plus 1 of x factored out from this expression, so that's positive 1 because that's positive because it's actually distributed right here. So we have 1 and then plus ln of cosine of x. Okay, so I think this is it's a lot simpler. Okay, so we can further simplify this. I think this will be the last one, so I'll be getting x squared and then plus 1 divided by 2x squared. So I think that's the best expression that we can have here. And then this one, I can also do something like cosine raised to sine x, and then multiply this. Since this is cosine over cosine of x, I can actually do something like secant of x, so that I don't have any negative expression or negative exponent right here, because that actually becomes cosine of x raised to sine x over cosine of x, and that's actually secant x, and then plus this whole expression. I think this is the best form that we can have here. Okay, so by the way, expressing this in terms of the simplified form depends upon you. So if something like you find this one already simplified, then you can already stop with that. But I'm just doing this because I don't know, just want to show you other ways that we can express the answers. So the answers that are considerably correct start from here. Actually, this one is already correct, so you can just box this, and all the remaining answers below this can be considered correct already. So you can just box them all out, and then you already have the answer. Let me just check the answer on our module. Okay, so the answer from the module is given something like this. So okay, we got the first term, and then of course for the second one, and then for the third, yes, we did the same. Okay, so we got this. So this is the answer from your module, the first one, and it is simplified further into this, but I think actually we added this in terms of just one expression, but the rest I just copied it from this, I think. And anyway, so this is another answer that you can give. This is also another answer that you can give. This one's also another answer. There are a lot of varieties for this, but the bottom line is that you just need to get the correct answer. And if you're finding it difficult to simplify, then the best thing is to let the first answer that is kind of multiplied to the respective numerator denominator, you can let them as it is and then box it. That's your final answer, I guess. Now, if the problem states that you need to simplify it in a way that I need to see, for example, only exponential function or any, or I just want to see all of it as if it's just trigonometric function without any, let's say, logarithm. So you need to simplify that further. For example, in this case, I don't want to see any hyperbolic function, so you need to simplify this further in terms of exponential. So in this case, this narrows down into this kind of expression. Okay, so I think I'm done with the transcendental functions, and once you're getting confused with what I do, just go back with the rules, because I think that's the bottom line of you not understanding this. I'm just applying the basic rules at the first, because the basic idea on how to internalize this is just you look on the outside. So if you try to look on the outside, you slowly go to the inside of the expression, and then you understand how this should work. That's the case, for example, this one on the outside looks like it's just two expressions multiplied together, and then on the inside of these expressions you would see the small functions that are involved in this one. If you try to like let this in terms of u, and then this one is v, you would understand that this looks very simple. Okay, so I think that's all. I think that's the best advice that I can give you for now, and aside from suggesting you to practice, because that's the only way that you can be good at this subject. Practicing means that you try to actually solve problems. It doesn't mean that when you watch this, you already know it. It doesn't work that way. Mathematics is a practice subject. So the only way that you can get better is to practice yourself and get a good, something like what you call a habit. When you, in mathematics, it's also like that. When you try to always solve problems, and then it tends to be a part of you when you try to solve a lot of problems in mathematics. I don't know if you feel that way, but sometimes it gets to something like you're doing it naturally. I don't know how to explain it, but when you have mastery over this calculus, you'll just develop this kind of natural instinct of how to attack the problem. And when the time comes, keep practicing. You'll be able to ace any problems in calculus. Okay, so I'll be hoping for that day to come, and for sure you'll be prepared when the other calculus subjects come. Okay, so thank you and stay safe.